To get started today, I want to look back at that chart that we made with some of our ways that we can factor. We had a pretty good list of strategies that we have learned so far. We're going to add to this one more new strategy to factor, and that is if we would happen to have a difference or a sum of cubes. Now, a sum of cubes would be in this form, a to the third plus b to the third. So it could be x cubed plus 8, 8x cubed plus 27, okay? Things like that where I have perfect cubes. If you have a sum of cubes, we can use this little formula to factor that sum of cubes. So a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And then if you have a difference of cubes, a cubed minus b cubed, that factors very similarly a minus b times a squared plus ab plus b squared. All right, now let's use these formulas. I know this is kind of crazy to look at. So we'll actually use our formulas here in example 3. And in example 3a, we are going to factor a sum of cubes. In my equation, we're going to start off with 2x to the third equals negative 54. Your first thought very possibly might be here, well, okay, everything is divisible by 2. Can't I just divide both sides by 2? Yeah, we might as well do that. Let's divide both sides by 2. And we get x to the third equals negative 27. From here, well, how do I get rid of this third power? Okay, maybe we don't know how to do that. But what we can do is make your equation equal 0. Add 27 to both sides. We get x to the third plus 27 equals 0. And this is a sum of cubes. Okay, this is a sum of cubes because x to the third power is x cubed. 3 to the third power is 27. Okay. Now some of those common cubes that you might want to know. So 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. Now we really won't go any more than that. I guess the next one you might see 6 to the third power is 216. But again, we really won't see any higher than that. Okay, but now that we figured out I have a sum of cubes here, I'm going to rewrite that sum of cubes formula. Which was a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. We figured out here what cubed gives us x cubed, what cubed gives us 27. So everywhere in our little formula, a is really going to be an x. Everywhere we see a b is really a 3. a cubed plus b cubed factors to be a plus b times a squared minus ab minus 3x plus b squared, which is 9. And we want to find when does that equal to 0. Okay, so from here, well, x plus 3 equals 0 when x is negative 3. X squared minus 3x plus 9 equals 0. All right, this doesn't factor. I don't have any numbers that multiply to 9 and add to negative 3. I can't square root because I have this middle term. I can't complete the square. Well, you could, but the fractions would make this messy because my b value is odd. So my best bet is to use the quadratic formula. Quadratic formula, remember, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's substitute everything in that we can. B here is negative 3. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we just have a whole lot of simplifying to do here. Negative 3 is positive 3. And this is 9 minus 36 over 2. Three plus or minus square root of negative 27. I'll keep working this way now. All right, the square root of negative 27, I have a negative underneath, which means I can pull an I out. And also 27 is 9 times 3, and that 9 we can square root. The square root of 9 is 3. With that negative underneath, we end up with 3i radical 3 here once we simplify our square root. For our final answer, 3 plus or minus 3i radical 3 all over 2. Along with our previous solution, x is negative 3.